All right, and we are on day 2 of complex numbers. All right, equivalent complex numbers. It says simplify the left and the right side. The real part on the left has to equal the real part on the right. The imaginary part on the left has to equal the imaginary part on the right, and then simplify each equation. So they're saying find the real numbers x and y that make the equation true. Well, if you're looking on this side, the -5 is the real, the 3i is the imaginary. This doesn't have an I, so that's real. This has an I, so that's imaginary. And what this says is the real part on the left has to equal the real part on the right, because they're claiming that these are equivalent complex numbers. So -5 has to equal x, and -3i has to equal positive yi. So once you set that, then you get x and y alone. Well, x already is alone, so x has to be -5. To get y alone, divide by I, and y has to be -3. Done. Okay, they're going to get a little more complex. All right, if I simplify, nothing's to distribute, so I have -6 minus 7i minus 2 equals x, distribute the negative, plus 3 minus yi. Okay, so now I can combine like terms here, and I get -8 minus 7i equals x plus 3 minus yi. Here's what you have to look at. This does not have an I. Neither do these on this side. This has an I, and so does this. So yellow has to equal yellow, and orange has to equal orange. So -8 has to equal x plus 3, and -7i has to equal -yi. So now to solve for x, I'm going to minus 3, and I get x equals -11. Divide by -i, divide by -i. The i's cancel, the negatives cancel, y is alone. The negatives cancel, the i's cancel, and y equals 7. Okay. Alright, you try this one, hit pause, come back when you're ready, and hopefully you got 2. Again, over here, no I, no I. I. So orange has to equal orange, and yellow has to equal yellow. So 7 has to equal x, and yi has to equal -6i. So x equals 7. Divide by I, y equals -6. Okay, try this one. Hit pause, come back when you're ready. Alright, we're going to have to do some simplifying here. Nothing distributes, so 4 plus 2i minus 3. Distribute the negative on this side. You're going to get x positive 4 minus yi. Combine like terms. 4 minus 3 is 1, plus 2i equals x plus 4 minus yi. And no I, no I. So yellow has to equal yellow, and orange has to equal orange. So 1 has to equal x plus 4, and 2i has to equal -yi. To get x alone, I'm going to minus 4, and I get -3 equals x. Divide by -i, divide by -i, and y equals -2. Okay? Alright, so again with the identifying the real and imaginary parts, we've already talked about that. Complex conjugates and their products. The whole purpose of multiplying by conjugates is to get rid of something, usually radicals or i's. Okay, the conjugate of positive ai is -8i. The conjugate of a plus bi is a minus bi. The product of your complex conjugate will cancel the i's. Always. Alright, so it says find the product, which means multiply, of the complex number and its conjugate. There's my complex number. Its conjugate would be -6 minus 3i. You don't change the sign in front, you just change the sign in the middle. So now I'm going to distribute. -6 times -6 is positive 36. Negative 6 times negative 3i is positive 18i. Then the next one goes, positive 3i times negative 6 is negative 18i. Positive 3i times negative 3i is negative 9i squared. And if you look again, combine in the middle, replace I squared. The 18i and the negative 18i cancel out, and they always will if you're multiplying conjugates. And the I squared on the end is going to turn into a real negative 1. So now when I distribute, I have 36 plus 9, which gives me 45. Okay, when you multiply a complex number by its conjugate, your product, your answer, won't have any i's left in it. Alright, you do this one, hit pause, come back when you're ready, and hopefully you got number 1. The conjugate of negative 7 minus 6i would be negative 7 plus 6i. So if I distribute, negative 7 times negative 7 is 49. Negative 7 times positive 6i is negative 42i. Then the next one goes, negative 6i times negative 7 is positive 42i. Negative 6i times positive 6i is negative 36i squared. Combine in the middle and replace I squared. These two are going to cancel because they're conjugates. I squared turns into a real negative 1. Distribute then, and I get 49 plus 36, which is 85. Alright, when they give you radicals, don't panic. The conjugate is going to be 4 minus the square root of 3i. When we distribute, 4 times 4 is 16. Positive times a negative is a negative 4 square roots of 3i. In the middle, this is going to be positive 4 square roots of 3i. And on the end, that's going to be a negative square root of 9i squared. Okay, so in the middle, they cancel. They better because we're doing conjugates. This is going to get replaced, and I can actually simplify the square root of 9. So I have 16 minus minus 3 times negative 1. This turned into 3, that turned into negative 1. Distribute, and I get 16 plus 3, which is 19. Okay, alright, you do this one, hit pause, come back when you're ready. Hopefully you got 1. If you didn't, let's look at y. The conjugate would be negative 5 minus the square root of 3i. So if I distribute, negative 5 times negative 5 is 25. Negative 5 times a negative is a positive 5 square roots of 3i. Next one goes, this is going to be a negative 5 square roots of 3i. This is going to be a negative square root of 9i squared. Combine in the middle, they cancel. This is going to turn into 3, and that's going to square root of 9 is going to turn into 3. And I squared is going to turn into negative 1, so I have 25 minus 3 times negative 1. Distribute the negative, and I get 25 plus 3, which is 28. Alright, so what is a complex conjugate and what are they used for? A complex conjugate, for a plus bi, would be a minus bi. And what are they used for? To eliminate i's. Mostly in denominators, because guess what? You are not allowed to have i's in the denominator of your fraction. Okay, so to rationalize, or they're going to call it dividing complex number, you really don't. You can't divide by a complex number. What you do is you multiply the numerator and the denominator by the conjugate of the denominator, and then simplify. So it says write the expression in standard form. You cannot, you'd be done, except for you can't leave that I in the denominator. To eliminate i's, we use conjugates. I don't care about the I on top, just about the I on bottom. The conjugate of negative 4 minus 8i would be negative 4 plus 8i. Only rule is if you do it to the bottom, you have to do it to the top. So on top, I have 1 times negative 4 is negative 4. 1 times 8i is 8i. Then the I crawls. I times negative 4 is negative 4i. I times 8i is positive 8i squared. And just like always, we're going to combine in the middle and replace I squared. So I have negative 4 plus 4i plus 8 times negative 1. Distribute, I have negative 4 plus 4i minus 8. Combine like terms, I have negative 12 plus 4i. There's my top. Now I've got to do my bottom. On bottom, negative 4 times negative 4 is positive 16. Negative 4 times 8i is negative 32i. Negative 8i goes. Negative 8i times negative 4 is positive 32i. Negative 8i times positive 8i is negative 64i squared. Combine in the middle, replace I squared. These are conjugates, so the middles cancel. And I'm going to replace I squared with a real negative 1. Distribute, I get 16 plus 64, which gives me 80. So 80 is going to be on the bottom. My solution is negative 12 plus 4i all over 80. Now, the only thing is I can reduce all of those by a factor of 4. So 4 goes into 12 3, 4 goes into 4 once, 4 goes into 80 20. So my final answer is negative 3 plus 4 plus I all over 20. Okay? Alright. On this one, before we can even multiply by the conjugate, we have to simplify on top. So on top, I have 1 times 1, which is 1. 1 times I is I. Negative square root of 7, I times 1 is negative square root of 7, I. Negative square root of 7, I times I is negative square root of 7, I squared. Alright? Ooh, this one ain't going to be pretty. So this I squared turns into a negative 1, so I have 1 plus I minus the square root of 7i minus the square root of 7 times negative 1. That gives me 1 plus I minus the square root of 7i minus, or plus the square root of 7. And to put this in standard form, I put my reals, so 1 plus the square root of 7 plus I minus the square root of 7i. There's my top. Simplified. Now I have 1 plus the square root of 7i. So now to simplify, I need to multiply the top and the bottom by 1 minus the square root of 7i. But I have to do it to the top as well. Oh. You know what I just noticed? I am going to be multiplying by the conjugate of this, which if I multiply by that one on top first, it might make this less irritating. Let me try that. Watch what happens, because see right here, we're going to have to crawl 1, 2, 3, 4, 5, 6, 7, 8 times. We can do it. We didn't do anything wrong. I just think this might be simpler to do it the other way. If I just start off going, look, I know I'm going to have to multiply the top and the bottom by the conjugate of the bottom, which is 1 minus the square root of 7i. And I know I'm going to have to do that on top as well. On top, they want me to multiply all 3 of those things together. Well, you can multiply in any order you want. So what I'm going to do is I'm going to multiply the 1 minus square root of 7i times 1 minus the square root of 7i. And then I'll multiply by the 1 plus I. So I have 1 times 1 is 1. That's going to be a negative square root of 7i. That's going to be another negative square root of 7i. And that's going to be a positive square root of 49i squared. Well, if I combine in the middle and replace the square root of 49 with 7 and I squared with negative 1, and combine those, I have 1 minus 2 square roots of 7i plus 7 times negative 1. That, if I combine or distribute, I get 1 minus 2 square roots of 7i minus 7. Combine like terms, I get negative 6 minus 2 square roots of 7i. But I still have to multiply that by 1 plus I. Alright, don't forget that third one on the top. Okay, so now if I distribute, and I'm just working on the top, I have negative 6 times 1 is negative 6. Negative 6 times I is negative 6i. Negative 2 square roots of 7i times 1 is negative 2 square roots of 7i. Negative 2 square roots of 7i times I is negative 2 square roots of 7i squared. To clean this up a bit, I can't combine those because he has a radical, he doesn't. But this is going to turn into a real negative 1, so I have negative 6 minus 6i minus 2 square roots of 7i minus 2 square roots of 7 times negative 1. Distribute, and that makes negative 6 minus 6i minus 2 square roots of 7i plus 2 square roots of 7. Now, you should put this real at the front, so I have negative 6 plus 2 square roots of 7 minus 6i minus 2 square roots of 7i. Doesn't look very simplified, but that's it on top. This is as much as I can do. I can't combine radicals and non-radicals. So now on the bottom, we're going to have 1 times 1 is 1. 1 times a negative square root of 7 is a negative square root of 7i. Square root of 7i times 1 is a positive square root of 7i. Positive square root of 7i times negative square root of 7i is negative square root of 49i squared. The 2 in the middle cancel because they're conjugates, and I have 1 minus 7 times negative 1. We replace this with 7, this with negative 1. That's 1 plus 7, which is 8. So my denominator is an 8. And if you notice, all of the outside numbers are divisible by 2, so 2 goes into 6, 3, 2 goes into 2 once, 2 goes into 6, 3, 2 goes into 2 once, 2 goes into 8, 4. So simplified, I have negative 3 plus the square root of 7 minus 3i minus the square root of 7i all over 4. All of that just so we don't have a radical in the denominator. Alright, you try this one. Hit pause, come back when you're ready, and hopefully you got 3. If you did not, let's look at why. I have to multiply the top and the bottom by the conjugate of the bottom, which would be 6 plus 8i. On top, 9 times 6 is 54, 9 times 8i is 72i, 2i times 6 is 12i, 2i times 8i is 16i squared. Combine the i's in the middle and replace I squared on the end. I get 54 plus 84i plus 16 times negative 1. Distribute 54 plus 84i minus 16. And combine like terms, 54 minus 16, and you get 38 plus 84i. There's my top. On bottom, 6 times 6 is 36. That's going to be a positive 48i, negative 48i, negative 64i squared. Combine like terms in the middle, replace I squared on the end. They cancel because they're conjugates. So I have 36 minus 64 times negative 1, which is 36 plus 64, which is 100. And you're done. I mean, you're done, but where did they get this answer from? Well, the first thing they did was everything was divisible by 2. So they said 2 into 38 goes 19, 2 into 84 goes 42, and 2 into 100 goes 50. So they wrote 19 over 50 plus 42i, or 42 over 50i. Now, how did they get to here? Well, you can't reduce 19 and 50 because they don't have anything else in common. But the 42 and the 50 can be reduced by 2. 2 goes into 42 21 times, 2 goes into 50 25, and that's how they ended up with 19 50ths plus 21 25ths I. Okay? Alright, you do this one. Hit pause, come back when you're ready, and hopefully you got 1. If you did not, again, what I'm going to have to do is multiply the top and the bottom by the conjugate of the bottom, which is going to be 2 minus 3i. On top, we're going to have to multiply all three of those things together. I'm just going to do 2 at a time. 1 times 3 is 3. 1 times negative I is negative I times 3 is 3i. I times negative I is negative I squared. Combine in the middle, replace I squared. I get 3 plus 2i minus a negative 1. That's 3 plus 2i plus 1. And that's 4 plus 2i. That's those two. I still have to multiply by 2 minus 3i. So if I FOIL that out, 4 times 2 is 8. 4 times negative 3i is negative 12i. 2i times 2 is 4i. 2i times negative 3i is negative 6i squared. And combine in the middle, replace I squared. I have 8 minus 8i minus 6 times negative 1. Distribute 8 minus 8i plus 6. Combine 14 minus 8i. There's my top. On bottom, 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times 2 is positive 6i. 3i times negative 3i is negative 9i squared. Combine in the middle, replace I squared. Those cancel because they're conjugates. That gives me 4 minus 9 times negative 1. That's 4 plus 9, which is 13. There's my answer. Again, they just split it up. They say 14 over 13 minus 8 over 13 I. But it's the same thing. Alright, so how do you divide complex numbers? You multiply numerator and denominator by conjugate of denominator. Alright, solving quadratic equations using the quadratic formula. And remember, this piece inside is your discriminant. If that discriminant, if the value, in other words, if you do the math underneath there and you get a positive number, in other words, greater than 0, then there's no drama, which means you're going to get 2 real solutions. If you do b squared minus 4ac and it's exactly 0, then you're going to get 1 real solution. It's going to be tangent. And if b squared minus 4ac is less than 0, meaning negative, then you're going to get 2 imaginary solutions, or no real solutions. Why? Well, where does b squared minus 4ac live? Under a radical. And under a radical can never be negative, or it comes out as i's. Okay? Alright, so skipped one I think. So we're going to solve this equation. Your quadratic formula, which you should memorize, negative b plus or minus the square root of b squared minus 4ac all over 2a. In a quadratic equation in standard form, a is whatever touches x squared. So a is 1, b is whatever touches x, and c is the constant. So if I plug those into my formula, I'm going to have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's going to give me negative 1 plus or minus the square root of 1 minus 12 over 2. That's going to be negative 1 plus or minus the square root of negative 11 over 2. Get that negative out. Negative 1 plus or minus I square roots of 11 over 2, which means I'm going to have 2 imaginary solutions. If I graph this thing, it will not touch the x-axis because its roots are imaginary. Okay, you try one, hit pause, come back when you're ready. Hopefully you got 4. If you did not, let's look. Alright, A is 1. B is 1, C is 3. Let's just do this one. Yeah, we did. Well, that was silly. Oh, sorry. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Yeah, let me show you how they got their answer in here. So that's going to be negative 1 plus or minus the square root of negative 11 over 2, which we pulled out the I. And what they do is they split it. So they have negative 1 over 2 plus or minus the square root of 11 over 2, and then they put their I on the outside. But there's nothing wrong with our answer, written just like that. Okay. Alright, so what does a negative discriminant mean? It means you're going to have two imaginary solutions. It means that the parabola won't cross the x-axis. Alright, and we are at homework, so happy homeworking, and I will see you next time.